In another video, I showed you how to calculate a difference of two means using a handheld calculator and doing hand calculations. In this video, we're going to solve the same problem, but we're going to use SDA and show you how to do this kinds of problem on a larger data set. First, I'm going to show you where the numbers came from when I did the problem by hand. So here we are at our opening page on SDA. I'm going to come up on and hover over the Analysis drop-down menu, and I'm going to come over and highlight and then click on Comparison of Means. My dependent variable had the mnemonic HRS1. That stands for the average number of hours that the respondent worked in the past week. My row variable is going to be the variable I compare across, my categorical or dichotomous variable, and I used the variable sex, so we compared the number of hours that men and women worked. You may remember that I restricted my sample only to people who had never been married, and they're coded 5 in the General Social Survey, and I also restricted my sample to the year 2012. This selection filter will get exactly those cases. I want to make certain that I've selected no weight, and most of the other things I can ignore. However, I don't want complex standard errors, I just want the standard deviation. I'm going to leave weighted n checked. In this case it doesn't matter because I've said no weighting, and so the weighted n and the regular n will be identical, and I don't need a chart of this. Let's go ahead and run the table. You can see in this particular table I have the same numbers that we used in the other video to calculate the test statistic. And the graphic I'm showing you shows you the formula for the difference of means test, and that we calculated this by hand and got a t-statistic of approximately 2.63. And depending upon our alpha level, this would lead us mostly to reject the null hypothesis. If we used alpha two-tailed 0.05 or 0.01, we reject the null hypothesis. If we used alpha 0.001 two-tailed, we would fail to reject the null hypothesis, given our t-critical values of 1.96, 2.58, and 3.29. But let's look at how we can solve this without having to use a handheld calculator and get these particular numbers. I'm going to close this window and come back to my SDA and go to my analysis window, and this time I'm going to come over and use, as I hover over analysis, I'm going to use their multiple regression program. Now, we haven't covered multiple regression, but what we're going to do is we're going to trick SDA into doing a difference of two means problem. Some of this is easy and just requires a little bit of recoding. Our dependent variable, again, is our hours, average number of hours worked in the past week. And our independent variable is going to be our sex variable. But now I have to recode the sex variable, and I'm going to use a temporary recode here. And I'm going to make the men equal to 1 and the women equal to 2. And you may remember how we did this. After sex, I put in open parentheses and R colon to let SDA know I'm doing a recode. I'm going to say I want 0 to be equal to the 1s in the original variable, and I'm going to go ahead and give that a label of male, just to help me keep things straight. And then my next part of my recode, I need a semicolon to separate, and I'm going to recode all the women who were originally coded 2. I'm going to make them equal to 1. So I'll say 1 equals 2, and I'll label this female. I still need my selection filter down here. You can see I've already entered this before, so I'm just going to select this from the drop-down menu. Make certain I don't have a weight selected. I don't need any global tests. I want the t-test, and I have a 95% confidence interval if I would like that. But I'm going to ignore that and just take the t-test. I think we're ready to go here. And I run my regression. And most of this you can ignore, but I'll point out two particular numbers in here. First of all, the t-statistic we get, minus 2.619, or we could round it, minus 2.61, is virtually identical to the 2.63 that we got when we calculated this by hand. Now, this coefficient, this t-statistic, is negative, and the one we calculated is positive. Turns out that that's not a big issue. They're the same number, one positive, one negative, and the issue here is if you look at the numerator of our formula, are we subtracting the average number of hours of men minus women or women minus men? Whichever way we do it, we're going to get the same difference, but in one case, the difference will be negative, and in the other, it will be positive. And all we've done here is SDA has calculated this differently than we did our handheld calculations. If I wanted it to be identical, I could go back and code the men equal to 1 and the women equal to 0, and I would have gotten the same answer. The other number I want you to see is under that column labeled B, we get a number minus 4.44. That number is the numerator of our t-statistic formula. That is, that's the difference in average number of hours that men and women work each week, and in this case it's women minus men. The 35 minus the male, the 39.4. Now, we don't get exactly the same numbers, partially because when you do these by hand with a calculator, you don't get the same precision as the computer. But by hand, I got 2.63, and using SDA, I got 2.62, and I'm pretty satisfied with those results. To summarize, if you want to do a difference of means test in SDA, you need two variables. Your dependent variable should be your continuous variable, the variable that the average gets calculated for. Your independent variable needs to be a dichotomous variable, discrete dichotomous, and it has to be coded as 0 and 1. It doesn't matter which category is 0 and which is 1. Men could be 0, women 1. Men could be 1 and women 0. All that happens is it changes the direction of the numerator of the t-test. And then you simply run the regression and you'll get the t-statistic that we showed here, same one you would get by calculating by hand, and you get this coefficient called B, which indicates the difference in the average between your two categories. I hope this video is helpful, and as always, if you have any questions, please let us know and we'll try to answer them.